So for the designer guys out there, there are a few different files in the folders. One is an STL, which is a bool cut, and one is a step file. So if you're using a CAD system like Fusion 360 or SolidWorks or anything that can handle the engineering step file, there is a file there called JP Clip Bool Cut Bodies version 1.step. And obviously if it's DIN or Boba, you'll pick the right one because the spacing between the two is a bit different. So on screen right now, what I have is the STL for Boba, but it's very similar on Jarin, just the spacing's a bit different. So what we see here is the bodies that will need to be subtracted from your model to allow our parts to fit and the print parts to fit. So effectively what we have here, if we just look at these blocks, these are basically the solid blocks and the holes required to screw into the body. Obviously the user's going to have to put something in there for threads, or you can design something in like a nut. These are M3 fixings for these parts. So if you want to design in a nut on the inside, or at least make clearance for them to put a nut or a nylock, something like that would be great. But this, if you at least have this cut from your body, it'll allow physical compatibility with our parts. This outside part, this first surface here is basically the back side of the ring that goes on the back plate. So this needs to be exposed and in free air, and this is the cut through your back plate, which will be the screws. These are M2.5mm, so they're quite small, but that's just the nature of it. It's pretty small. And this part here is a cutting body to allow the plate. There's a threaded plate to cut through the inside of your body. Now I'll share some pictures with you so that you have an idea of what that looks practically on Jarin's, who I've done the prototype on, but hopefully that makes sense for that. Then we'll jump down to the fidlock part. So we'll talk about the inside first. So this body basically allows for the real world fidlock piece to fit, which is this part here. You'll notice there's an extra cutout on the top. That is to allow for the function of the actual thing to work. So this top cutting area you see here basically allows clearance for this to come up and for the clip to functionally work. So you will need to cut both the bottom and the top, and you know, obviously they're going to need access to this bottom area here to be able to physically, you know, push it and slide that bottom part up. So you'll have to take that into your own design consideration, but we can chat about that. On the back, you'll see that there's there's three cutting holes. So the first top one and the bottom one are for these little locating pins that are on the original found part. That just lets this sort of fit in. And the center one is an M5 hole. In terms of depth, it's entirely up to you how much depth you want to put in there. Obviously, allow the user some space to either put like a threaded insert or a nylock nut on the back of that, which will allow for this found part to fit. This is a cutting body, so it's physically larger than the actual part, but it'll give clearance enough that it should work fine. On the outside here, we have basically this flat plate, which represents the base of this piece here, which is the part that goes on the jetpack. And this is exactly the same as what we've done for the disc mounts up above. So that flat surface here, this flat surface here, needs to be on the outside of your back plate. And these are M4 holes, which is what this accepts. And if you're wondering what these raised parts are on the end here, these are 10mm diameter cylinder cuts, so that nuts can be fitted. So that's the outer diameter of a flange nut that could be fitted in the hole. Obviously these depths, it's up to you. You can change that, but this is just a guideline to give you an idea. So that's effectively it for the cutting body, and I'll switch really quickly to the parts in place themselves. Hopefully you can still see that. Let me just rotate because it's a little bit difficult in this view. Yeah, there we go. Okay, so basically those first bodies you saw were the cutting bodies, and these are the actual print bodies in place. So if you want to line them up with your model and just check that everything is kosher, obviously, you know, you can go ahead and do that. So these blocks are the physical blocks that go into jetpacks, and this is our sort of fidlock replica piece for people to use. As I've said in the license and my post, this is free for you to use. Feel free to include it. It is literally the data that we are either manufacturing with, or, you know, a direct dimensional replica of this. If you make your own, absolutely feel free to, but please maintain, key dimensions, certainly that are connecting between the two, so that people have interchangeability between the systems. If you do deviate, sure, go for it, but I would just quote for people, so at least they know that it's not necessarily going to be cross-compatible. So yeah, you can include these, you can sell them as part of your kit. I have no financial want from this. The only thing I ask is that you cite us as the designer. And obviously, once we get the link up for the listing, we ask that if you can, please share the listing. We're not going to make that mandatory, but if you can, we'd really appreciate it. So yeah, that's it basically. If you want to integrate these into your backplate, these are called Fidlock cube blocks. They were discontinued a few years ago. We managed to buy the last 500 from Fidlock directly, so we have hopefully an amount that isn't going to run out anytime soon. But yeah, if you have any questions or any doubts, feel free to hit me up. I've spent a good few hours researching this, and yeah, I feel pretty good about it. And I'm pretty excited to get out in the world. So yeah, if you got any questions, just hit me up. Thanks very much for contributing.